Hey everyone. So basically, this is the last lecture of our very first chapter, which is real numbers. This is a recording of it, and basically, we don't have much to study today. We are ending up the chapter in this lecture. We'll just wind up. So, first, what we have to study basically is fundamental theorem of arithmetic. Basically, this is nothing. It just means that every number has a unique prime factorization and it can be expressed in only one unique way if we keep if we ignore the arrangement, right? That means अच्छे से बताओ तो हर नंबर की एक अलग प्राइम फैक्टराइजेशन होती है और उसका एक ही यूनिक वे होता है. अगर उसका जो रीअरेंजिंग है उसको इग्नोर कर दो, एक ही प्राइम फैक्टराइजेशन होती है. फॉर एग्जांपल, टेक एनी नंबर 42, right? 42 equals 2 into 3 into, wait a minute, 3 into 7, right? That's the prime factorization. What does the fundamental theorem of arithmetic says? That 42 के अलावा किसी भी नंबर की ऐसी, and also 1 is always the factor of it and not the prime factor, which is a unique number. 1 is neither composite nor prime, it is a unique number. So now एनी कोई और नंबर की प्राइम फैक्टराइजेशन 2 into 3 into 7 नहीं होने वाली, सिर्फ 42 की होएगी. एंड 42 की सिर्फ एक ही प्राइम फैक्टराइजेशन अरेंजमेंट है, ये है 2 into 3 into 7. अगर उसका जो अरेंजमेंट ऑर्डर है आप उसको नेग्लेक्ट कर दो तो दिस इज जस्ट द फंडामेंटल थ्योरम ऑफ अरिथमेटिक, सेज नथिंग एल्स, right? And one more method I would like to teach you, which is basically for 8th students who are studying the 10th class syllabus. This is a method which you must know and which is very helpful for you. Now, do you know if I tell you a number x, wait a minute, x, if it is equal to, let's say 2.6 and a bar on the top of 6. Do you know how to convert it into a rational number with a proper method, with a proper subjective method? Basically, this is a part of 9th class syllabus, but you need to learn that. So what is the first step? Multiply both sides by 10. See, you can, you obviously know what does x mean. X equals 2.666666666, right? So we are writing it as 6 bar, or you can, okay, I'll just write it down for you. X equals 2.66 and so on And this is our equation number 1. Right? This is our equation number 1. So what we're gonna do, see how many digits have a bar on them? Only one, which is 6. Only one digit has a bar on it. So we'll multiply both sides by 10. And if if wait a minute, multiply both sides by 10, right? If you multiply both sides by 10, if say let's say two digits had a bar on them, say if x equals to 2.65 raised to bar, if both the digits 6 and 5 had a bar on them, then we would multiply both sides by 100, right? Is that clear? So if we multiply both sides, what do we get? 10x equals 26.66 and so on, right? We multiplied both sides by 10. uh, 10 into x equals 10x, and 10 into 2.6666 equals 26.6666. Like just one 6 is taken to the left side of the decimal, right? And now we'll take this as our equation number 2. Now a very simple step: subtract equation 1 from 2, as simple as that. So when you subtract the equation, what do you get? 10x minus x, that equals wait, 9x. 10x minus x equals 9x. Now I'll just write it on this side. See, 26.666 till infinity and 2.666 to infinity. If you subtract these, all the 6 would be cancelled out. 6 minus 6 equals 0, 0, 0. So all these terms after the decimal will be cancelled out, and what you're left with is 24.0. Is that clear? When you subtract 2.666666 from 26.666666, what do you get? 24. Right? Now just take the 9 to the other side, which is 24 by 9. And this is the answer. For the verification purpose, what you can do is just divide 24 by 9. The decimal expansion will obviously be 2.666666, right? Okay, we'll just have another example and then we'll just rush to the other side. I taught this because this was important for you to learn. One more example we have here is, let's take This time we'll take 3 digits on bar. This time, like, will not take a simple number this time. X equals, wait, X equals, this time we'll take 32.2863 and a bar on it. Now, it is obviously not necessary that all the digits after decimal will have a bar on them. So we have a digit here. Now, what we're going to do, how many digits have a bar on them? 3. So, multiply both sides by 1000. See, the number of digits, 3 digits, so 10 is to the power 3, which is 1000, multiply both sides by 1000. If the digits were 4, if 4 digits had a bar on them, if we took 2 as well to have a bar on it, we'd have 4 digits to on with bar on them. So 10 is to the power 4, 10,000, we would have multiplied both sides by 10,000. So multiply. What do you get? You get 1000x equals, now 3228 32,286 point 386 3863 and infinity. See, now I'm going to explain the step. Just write this as x is to be, wait, x equals 32.2. Now 863 have a bar on them, 863 863 863 till infinity. Wait, fine. So what we did was just observe the number of digits we had that had a bar on them. 3 digits. 10 is to the power 3000. Multiply both sides by 1000. What do you get? 1000 multiplied by x equals 1000x. And on the other side, just take 3 digits to the left side of the decimal, which is 32,286.386,386,386. Now, why 386,386? Earlier it was 863. See, what did you do? 286. See, we took 3 digits to the other side because we multiplied 1000 it. What was left? 386, 386, 386. Is that clear? Now, what we did was, this was equation 1. This is equation 2. And our next step, subtract equation 1 from 2. As simple as that. Well, now 1000x minus x, what is it? 999 x equals to, now we'll stick it to the other side. What was it? 322. What you had earlier was 3, 2, 2. We'll take it as a text form only. It was 32286. Point 386, right? It is 386 to infinity. And what do we have to subtract from it? We have to subtract 32.286 right? So now just subtract. What do you get? See, all those 386 will be cancelled out. What you're left with is 3 minus 2, 1. 4. 5. 3, 2, 2. So simply, what do you get? 999x equals 32254.1. Now just take remove the decimal, upon 10 will be there, and just take that 999 to the other side. What do you get? 322,541 upon 9990. Now I'm not going to do that, but what you have to do is just reduce them to lowest terms. Convert the denominator and numerator to co-prime numbers. That you have to do by your own. So this method must be practiced by you from the 9th class textbooks. That's a must. You have to do them, and that's your homework as well. To just prepare what I revise and just practice whatever the methods I've already taught you. Now we'll just have a glance on the exercise of 10th class, chapter 1. I'm already telling you to have this book is a must for you. If you don't have, free PDFs are available as well. We have done everything I taught you in terminating numbers, non-terminating, recurring, reoccurring, and repeating are the same thing, one and the same thing. And also I have a homework for you. The method I taught you just now, by that method, if x equals 0.999999 till infinity, what does that equal to in p by q form? You have to tell me. That's your homework for today. Just you have to text me on Telegram, and the homework must be there with me by Wednesday 8 p.m. Am I clear with you? The homework must be there with me till 8 p.m. on Wednesday. And your homework is just convert x equals 0.9999 into p by q form. Don't bother about the writing. right? And the last question of the first chapter of 10th class book, what they have is the following real numbers have decimal expansions given below. Decide whether they are rational or not. Simple. And what can you say about the prime factors of Q? See now. First of all, what they have is, wait, let me write it down. 0.12 1200 and in the same pattern the numbers are going on like that. See, I told you a number can be rational only if, like, either it is terminating or the decimal expansion must be non-terminating but reoccurring or repeating, right? But as you can see, 1201, 120, 1200, 12000, this is not like this is not repeating, right? So this is irrational number. And on the next part, what you have is, I'm just giving a hint to you all. The next part, all the decimal expansion have a bar on them. So if they have a bar on them, which means that they are reoccurring or repeating numbers, they are rational. And now you have to tell about the prime factors of Q. That is your homework basically. And let me see whatever is left. See, what do you have to tell about the prime factors of Q? You just have to tell it is of the form 2 raised to power m into 5 raised to power n or not, right? If it is obviously non-terminating but repeating, so it is not of the form 2 raised to power m into 5 raised to power n. But if you come to the first part, the decimal expansion is ending till 9. So that means it is a terminating number, which means the denominator, which is Q, has its prime factors in the form of 2 raised to power m into 5 raised to power n. And there is also a formula given, which I'll discuss now. Yeah, that was it. That was the chapter. And one more thing which I left to do, I'll tell you. See, on the last page, this is your homework. On the last page, they have given you a homework note, which is, if you have to find LCM of three numbers, what do you simply have to do? And you know, if you have to find LCM of three numbers and you know it's HCF, simply what you'll do, you have to find LCM of P, Q, and R equals P into Q into R into HCF of PQR now upon HCF of PQ into HCF of QR into HCF of RP. Similarly, if you find HCF, if you have to find HCF of three numbers PQR, just same way PQR into LCM of PQR into LCM of PQ into LCM of QR into LCM of RP. Same method is there. And one more thing, in the examples, I just told you how to prove root 2 is rational. They have also given you prove that 5 minus root 3 is rational. You will do, there are examples, the solutions are given side by side. You have to do themselves. You have to do yourselves. Same method is there, almost like it is same, right? So we are done with the chapter. All you have to do is now solve the questions, solve till exercise 1.4, and also I told you one more method from 9th standard. So do those type of questions from 9th standard books. Thank you. So that was it.